Hello everybody, this is Chris Mackey and this is your 5th Ladybug Comfort Tools tutorial, and the first of three actually, where we're going to be working intensely with this component called the Psych chart. And yeah, it's important. We need a full 3 series to cover all the things that this component can do, and so let's dive right in because we're gonna need all the time we can get. So I'm gonna start from the beginning in case people are jumping into the series here, and I'm just gonna drag a Ladybug component down onto the canvas. You always have to do this anytime you start using Ladybug. So we'll do that, and then instantly let's get ready. Let's take this psychometric chart component that's up in the visualized weather data and just drop that onto our canvas. It's just diving right into it here. Make a slider that goes from 0 to say like 30, and maybe set it to about maybe 20 degrees and hook that up to dry bulb temperature. And you can see actually, so even though this component is very large and comparable with the number of and length of videos that we're going to have on it, it's actually, you only really need 3 inputs. So inputs that are required have this dash in front of them. And so we really only need a dry bulb temperature, relative humidity, and to run it to true. And so that's what we're going to do quickly right now, just to dive right in and get started. So make a slider that's maybe got a value of 50 and hook that up for relative humidity. And then lastly, hook up a Boolean toggle to run it here. And you should see once you've hooked that up, it should instantly, or perhaps in a few seconds, boom, draw a psychometric chart right in your Rhino window. That's Rhino vector geometry right there of the psychometric chart that you can now use and play around with. And so, all right, so let's see. I mean, it's kind of in this sometimes a little ugly red color. So let's maybe just let's have everything preview in black just so it looks a bit nicer. And so we'll hook up the chart curves and text. Let's say the legend to that. We'll hook up the comfort polygons, which are the thing in the center. And then, I mean, we don't have anything for these right now, but strategy polygons we'll hook up as well. And then we'll just take a swatch component, because now it's kind of from ugly red to ugly hot pink. So all right, so now let's hook up black, and okay, and we got our psych chart looking nice, and we're ready to now understand it a little bit better. So to give you guys some background, the psychometric chart is basically, it's just a plot of dry bulb temperature, of air temperature on your x-axis, and humidity ratio on your y-axis. Now, humidity ratio is it's related to relative humidity, but it's actually specifically the exact mass of water vapor in the air divided by the mass of the air. So it's a little bit different. It's an absolute humidity as opposed to a relative humidity, which you may be more familiar with and which we're kind of hooking up here. So these are the swoopy lines here, are lines of constant relative humidity. And there's a certain, at 100% humidity, your relative humidity, you can't fit any more water vapor in the air. And that's why we get this distinct sort of swoopy curve shape to our psych chart. So now you guys got a basic understanding of what the psych chart is. I should let you know that so this is essentially it is the favored tool of the air conditioning industry and of mechanical engineers for designing HVAC systems and ensuring that they will satisfy comfort conditions. And in fact, perhaps the best proof of that is the fact that the psychometric chart was invented by the grandfather of the air conditioning industry, Carrier, who had started the Carrier company, which many of you may be familiar with. And he used this essentially to as I just said, to sort of evaluate the conditions that people were in, and see if they were comfortable. Now, I've kind of described basically what most lines are on the chart, but this comfort polygon here is now, this is the really important thing that's worth paying attention to. So this is essentially an area that represents the comfortable temperatures and humidities for people. And this is calculated using the predicted mean vote model, which many of you may remember from the second Ladybug tutorial, or Ladybug Comfort Tools tutorial. And so this is essentially using the relative humidity and the dry bulb temperature that we hooked up here, and is plotting out the area that's comfort using that PMV calculation. And so this only represents comfort in relation to thermal stress. essentially right now, what you get right here. But the thing is that there's a lot of assumptions that are going into this. And many of you who are watching this may be old enough to remember the time period back when we all had static psychrometric charts that we couldn't really interact with too much. And the thing is, it was harder maybe to get a sense of the assumptions that were actually shaping this polygon here. But that has changed in recent years. And I mean, I'm certainly not the first one. You will get into the interactive features of the Psych chart to do it. But the Center for the Built Environment has made this wonderful tool here that allows you to essentially change the different temperatures, change the and the air speeds around to essentially account for different types of comfort. And it moves this comfort polygon around the Psych chart. And so you can understand, like, okay, wow, I'm assuming that people are actually standing up in this. Maybe my person's sitting down. Okay, that has a different comfort shape. Or maybe they're actually wearing more clothing. They're not wearing shorts and a t-shirt like that. Maybe it's a little bit larger. And so I really found this tool very useful. And I wanted to just make it more accessible to myself and now also you wonderful viewers. And so I made this. This is essentially a replica of the Center for the Built Environment tool that's written in Python and outputs its Rhino vector geometry for you. So you can use it very quickly and access this like in the middle of design projects. And now, well, I showed you the interactive features on the Center for Built Environment tool, but let me now show off some of the things in this tool. So we can do things like increasing the wind speed. So maybe we'll make a slider that goes from 0 to 5 meters per second. And you can see, all right, we hook up the wind speed, and it's not going to change anything because it assumes, like as a start, that the wind speed's pretty low. But let's say we move this up to 1 meter per second. As you had kind of seen in the Center for Built Environment tool. And we see, after my somewhat slow processor churns through these things, hopefully it's faster than your computer, but you see the comfort polygon is shifted. It's now, there are much hotter temperatures that people will accept now when there's wind speed around them. And so you can use this to really experiment, and sort of see what the potentials are if your users maybe have a fan that would increase their wind speed that they'll use regularly. And maybe that might even eliminate your whole need for an air conditioning system. And then you could use this chart to argue for that elimination. But so let's say, there's also other things like metabolic rate. So there's a component here that has a bunch of list of activities, this Ladybug activities met list. And you can see just by clicking the arrow that it gives you all these possible activities. So you can see, all right, maybe the person isn't sitting, maybe they're house cleaning. Maybe, it's a different activity, and you could hook that up to the metabolic rate, and then it will move the comfort polygon again for you based on that metabolic rate that's common with house cleaning. And you see people actually like a lot colder temperatures because they're being more active when they're house cleaning than when they're sitting still. So you can begin to use this. You also have clothing level here, and you can really begin to play around and understand all the assumptions of comfort. And if you ever want to know specifically what exactly your assumptions are, this README here will always output for you what those are if you haven't input values for certain things. So it's assuming barometric pressures, it's assuming radiant temperature of 23 degrees Celsius, which could be very different than a real building, or that you're wearing a three-piece suit, all these things that you might want to play around with and really understand, so that you can customize it to the occupants that will be in your building. And you can see also, we also get out of this just in the same way that the CBE tool has this little point that you move around that tells you if it's comfortable or not. There's also a point that comes out of this, but it's hidden right now, but you can see chart hour points here. If you hook that up to a point, there's that little point on your chart. And you also get something that tells you whether it's comfortable or not as a series of zeros and ones, essentially. So that would be a value of 1 saying it's comfortable because it's inside the polygon there. So you guys get a sense of this, of how you can play around with this. But there are other benefits. This is meant to do a bunch of different things for you that are sort of an amalgamate a lot of my favorite psychometric chart tools into one sort of ultra design vehicle. So I think for the time being, all right, let's see. I'm going to get rid of these values and just run with the assumptions of of a person sitting and a wind speed, a low wind speed. And you can see that that's actually not comfortable right now, but we're gonna fix that. because I'm gonna hook up, so you can hook up lists as well. So I'm gonna hook up two possible clothing values. And so I'm going to do that by making a panel. Essentially, you can just hit quotation marks to make a panel. And then I'm going to type, let's see, I'll type a summer clothing value of 0.4, and then hit enter. And then maybe I'll type a winter clothing value of 1, or like a 3-piece suit, or 2 layers of clothing. And then all I have to do is just make this multi-line data by right-clicking and hitting multi-line data. And then we can plug that into our clothing level, and you'll see that we'll now get 2 comfort polygons. One that has a high sort of insulation value, and I guess these conditions are still not comfortable for me. Maybe I wasn't the best at guesstimating that. And maybe also we see that we're actually getting, so maybe this really merits 3 to kind of close that gap between them. But I also realize, 0.4 is actually probably close to being in my underwear. So maybe I'll be a little bit more easy on my occupants, not assume that they're going to be in their underwear, and say, okay, 0.6 clothing. And you can see now we get two polygons that essentially cover that. So that's one thing that you can do. Now sort of moving on, and you can sort of see if these individual conditions of dry bulb temperature and relative humidity are good for you. But what would be particularly awesome is if we could look at outdoor data, essentially, on our Psych chart in relation to our comfort polygons. And so in this psychometric chart supports that easily, so that, it supports individual values as we've done here, but you can also hook up EPW data from any Ladybug import. So to do that, I'm going to kind of start from scratch. Some of you may already remember from previous videos, but you just have to drag, not that component, drag the download EPW component onto the canvas, drop it on there, and then make a Boolean toggle and set it to true. And this will automatically bring you in your browser, in your default browser, to the database of all the Department of Energy's climate data. And so let's see. Let's look at New York. It's my homeland. I kind of like it. And so North America, USA, New York, and let's see. Let's go with New York John F. Kennedy Airport. And then all we have to do is essentially right-click on this and go to Save Link As. Oh, nope. Sorry, actually, it was not Save Link As. Actually, I rather wanted to do John F. Kennedy Airport TMY3. Copy link address. So that'll copy the link address to my clipboard. And then I can easily go in my Grasshopper window here, and just by hitting quotations, that'll start a panel, and then Control-V to copy paste that zip file address into Grasshopper. And now once I have this web URL for that climate file, all I need is a Ladybug import EPW and stat, which I just drag and drop onto the canvas. Some of you may already be kind of familiar with this workflow. And you hook up the weather file URL from the panel there. And then lastly, we need to import all the data from the EPW file. So this is just giving us a file location on our computer. So we'll grab the import EPW, drop that onto the canvas, and hook that up. And that will now import hourly values for dry bulb temperature and for relative humidity for every single hour of the year. And that is what we're going to, be plugging into our psychometric chart now. So I'm going to turn the Boolean toggle to false for a second, just so that it doesn't try to remake the whole psych chart until I have everything I want. And then I'm going to delete these individual values of dry bulb temperature and relative humidity and hook up these lists of dry bulb temperature. And actually, just so you know, in case you haven't seen this before, this is essentially, it's got a little header, and then it's got degrees Celsius values for temperature for every single value of the year. So we hook those into the psych chart, and then we hook up the relative humidity to the psych chart. And then we also, I know I didn't use this barometric pressure thing originally, but the EPW file gives you barometric pressure, and this is actually very useful, especially if you're looking at climates like Denver that are a mile in the sky, and the barometric pressure actually influences the amount of water vapor in the air a bit. So I would suggest plugging that in if you're using EPW data. And then so finally I'm going to set this Boolean toggle to true again. And this time when the psych chart regenerates in our Rhino window, we're going to get something, a nice surprise that will hopefully look pretty nice. Well, we're first getting a bunch of points because I left this thing there. But let's actually just delete that for now and realize, oh, that's a very nice pretty mesh, essentially a colored mesh that is showing us the frequency of hours where each of these conditions occur in the outdoor, in the EPW file. And so you can see there's a legend here. So the red values mean that the cell is 96 hours, where blue values are essentially 0. And you can see for New York climate, okay, we're mostly cool and humid. There's a lot of times where we get a saturation of 100% right at the edge of the Psych chart here. So that must mean that it's pretty damp. It must rain a lot. And you can see, wow, like, okay, thankfully our polygons are nabbing a big chunk of that mesh there, where we have a lot of the hours of the year in New York. And you can see, and you can actually double check that. So you can see also now, instead of just the single 1 or 0 value that we were getting out before, you get a list for every single hour of the year, and you get two lists, one for each of these clothing levels. Well, I'm gonna actually just delete this for now, so I can show you something else that might be more useful. So you also get the total comfort percent. So that's all the hours of the year that are inside these two polygons. And I'm going to pull up a panel here and connect this, and you can see, okay, actually about 29% of the hours of the year are comfortable in New York if we allow people to change their clothing this much in our building. And so for 29 hours of the year, we wouldn't necessarily have to be running HVAC systems, as long as people could change their clothing to make themselves comfortable. And you can imagine testing out a bunch of things like this, like increasing the wind speed to account for maybe people turning on fans, or even changing metabolic rate because people get more sluggish when it gets hot, etc. But so we'll leave it like this for now. And let's see. And the thing is, okay, well, it has been kind of nice to maybe have two different polygons here, because I mean it's maybe nice to see each clothing value next to each other. But at a certain point, it's a little distracting, and we might just want to merge them all into one polygon. And that is why we have a merge comfort polygon option here. And so I just pulled up a Boolean toggle. So if you just pull up a Boolean toggle and set it to true and connect it to merge comfort polygons, you'll now just get a single comfort polygon instead of those two. And that's useful for the territory that we're going to be going into. And you can see, yeah. So now it's a single comfort polygon. It's a little clearer to see sometimes, and that can you definitely want to do that if you start getting a lot of different wind speeds and all these different things that you want to hook up there. So that's one set of things. So now there's one other thing that I feel obliged to show you, which are going down all the inputs of this component. So we have comfort parameters. So believe it or not, there are more things that determine comfort than the 7 different variables that we have here that going into this model. And the thing is, so there's a standard that's been argued by ASHRAE, which is the American Society for Heating, and I never get through the whole thing. But essentially the authority on air conditioning and heating systems in the U.S. States that there actually should be some standards that say you can have conditions where people are not feeling thermal stress, which are defined by our comfort polygons here, but are actually very humid to the point that people feel kind of sticky. So even though it's cool and people are not feeling thermally stressed, people still might report some discomfort. And this is a highly debatable fact that is still that the building science community has been debating amongst itself for a long time. But the thing is that ASHRAE does recommend sort of setting a maximum humidity ratio. So not necessarily letting this comfort polygon be as large as it is. And it's sort of up to you to whether you want to do this, but I'm going to show you at least how to do it in case you do want to account for it. So there's a Ladybug comfort PMV comfort parameters component here that's in the extra tab of Ladybug, and if you drag and drop that onto the canvas, you will see that this includes things like a humidity ratio upper boundary. And so we can set an upper boundary, say like, I guess ASHRAE recommends 0.1, actually 0.012 actually as its upper limit on humidity. And so you can see, we'll just draw up a panel using a quotation mark, and we'll put that 0.012 and hit enter and hook that up to our humidity ratio upper boundary. And you can see out of this, then we get a set of comfort parameters that you can then we can then plug into the comfort part of the psychometric chart, and it will then limit the upper boundary of that comfort polygon. And you can play around with that, and so you see it cut out. Like, I mean, this is why, I mean, a lot of it's debated, because we're losing a huge chunk of hours for something that we're not necessarily, because not all people necessarily find humidity without thermal stress to be uncomfortable. But you know, sometimes in I guess more in like northern and western climates, where I mean the stickiness is associated with sweating, people might report some discomfort. So I mean, so it's debated, and it's your call. But you can see our total comfort percent has shrunk from the 30 almost to about 11 because of that. So all right, so we'll press onward with this. Still trying to sort of make these hours comfortable without having to really resort to full-blown air conditioning systems. And I guess actually maybe it's important to show right now before we like really delve deep. So we've essentially shown all that you can do as an occupant with, you know, clothing levels and met rates and wind speeds. But we'll show actually what you can do with building passive strategies shortly. There's just one last thing that I think is worthwhile to show you. So the thing is, you get I showed you total comfort percent and total comfort or not. And so this output, actually, I'm sorry, I may have said before that you get a grafted list. So total comfort or not is always going to be one list that includes everything in this comfort polygon. But you also get a strategy or not, which is, you know, if you have two comfort polygons, there's going to be a set of two lists coming out of there, one for each polygon. So we'll just take this total comfort or not, and because it has a header on it, and because it's, you know, a set of zeros and ones, we can take this directly and plug it into a Ladybug 3D chart. So if you just drag that Ladybug 3D chart and drop it onto your canvas, and I'm just going to drop the z-scale to 0 because I like it like that, and I view it in top view. And then we can drag the total comfort or not over to the input data. And that's then going to plot in our Rhino scene a sort of a chart that will show us which times of the year are comfortable and which are not. So you can see the red are the times that are comfortable, which actually, I mean, we said it was only 11%, so it's really not that great. And it looks like they're mostly occurring, say, in June, July, May, and I mean, it's in the winter where conditions are just too cold to be comfortable. So you can use that to get a sense, an initial sense of oops, okay, sorry about that, of what hours of the year are comfortable. And so I think that's enough for this video right now. In the next one, we're going to be moving into architectural strategies so that we could really sort of make more of these hours comfortable with sort of passive means without having to resort to using air conditioning and heating systems. So all right then, thanks everybody, and I'll see you in the next video.